Subtopic, I think, in the chapter 5 is 5.6, model selection. So by the end of this topic, you should be able to summarize the multiple regression analysis from the Excel output. Okay, because we will give you Excel output for the multiple linear regression. So you should be able to summarize the Excel output. And then you should be able to choose the most significant variable in order to achieve parsimony model. What does it mean by parsimony model? Parsimony model is less predictor variable, less x. Because multiple linear regression, we have more than one x, right? But we want to choose the model that have the most significant x. So we want to achieve parsimony model. What does it mean by parsimony model? Is your model that have less x. Okay. So, and then you should be able to use the best selected model to make prediction. Okay, first summarize the Excel output and then you choose the most significant predictor variable and then you use the model to make estimation. Okay, a simple way of model selection. Okay, in model selection, we consider the p-value from ANOVA table and look at here. The smaller the p-value, the better the model. Choose the smallest p-value. Point number 1. Point number 2 here, consider high value of r square and high value of adjusted r square. Okay, one condition is you look at the p-value and you choose the smallest p-value. And number 2, we look at the r square for simple linear regression and adjusted r square for multiple linear regression, and we take the highest value of the coefficient of determination. Okay, the procedure, right? When you have here, you can key in the data, alright. So note, if there are k independent variables, there will be a total possible of models. Okay, we will use 2 to the power of k minus 1 for the possible model. Okay, for example, like this. Okay, for the possible model, we will use 2 to the power of k minus 1. Okay, for example, I have my x, my predictor variable, or my independent variable, x1, x2, and x3. Okay, so my independent variable, I have 3. So means that k is equals to 3. So what are the possible model that I will have? So the possible model is equals to 2 to the power of k minus 1. 2 to the power of 3 minus 1, 8 minus 1 equals to 7. So I have 7 possible models. So what are the possible models? So you said that you have 7 possible models. So what are the 7 possible models? Means that y with 1x, y with x2, y with x3. This one is simple linear regression. And then y with x1, x2, y with x1, x3, y with x2, x3, and y with x1, x2, x3. So 1, 2, 3, 4, 5, 6, 7. Then you have 7 possible model. This is step number 1. Step number 1 in model selection is determine the possible model. This one. Step number 1, determine the possible model. How you want to determine the possible models? We use this formula, 2 to the power of k minus 1. What is k? K is your number of independent variable. So in this case, I have 3 independent variables. So k is equals to 3. So k is equals to 3, the possible model will be 2 to the power of 3 minus 1, you'll get 7. So what are the 7 possible models here? So I have 3 simple linear model and I have 4 multiple linear regression model. So between the 7 possible model, I will choose the best model. Okay. So just now you have step 1, possible model. Okay, 2 to the power of k minus 1. After you determine your possible model, and then step 2, you choose the model that have smallest p value. Okay, and then step 3, you choose the model that have highest coefficient of determination. If it is a simple linear, we look at the R square. If it is a multiple linear regression, we look at the adjusted R square. Choose the highest. For the p-value, choose the smallest. Okay. So these are the method. These are the way you want to choose the model, the best model. Okay. So look at this example. The following table summarizes the multiple linear regression for the response variable y. Okay, there's only one y with weight 1x. With variable y is the weight. And the predictor x is height. So the first x is your height. And the second x is the waist. And the third x is the cholesterol. So this example, they use x1 as the height h, x2 as the waist w, x3 as the c, cholesterol. So here is x1, x2, x3. Okay, so what are the possible model you will have? You have k equals to 3, x1, x2, x3. So 2 to the power of 3 minus 1, you will get 7. So the 7 possible model is here. x1, x2, x3, x1, x2, x1, x3, x2, x3, x1, x2, x3. In this example, they use this one. x1h, x2w, x3c. You can use the symbol like that. Okay. So from the Excel output, you have the p-value. So you jot down all the p-values, and then you have the R square, you have the adjusted R square, and the regression equation. Where can we get the regression equation? From the regression table, coefficient table, bawah sekali. Okay, first, what we look at? We look at the p-value smallest. Okay, the smallest p-value. So here, when you look at here, C you can discard. Why? Because C, the p-value is 0.8740 is greater than the alpha. Okay, so because of greater than this alpha, C is not significant. Right? So any combination with C you can discard because C is not significant. Right? So next you have HW, H alone and W alone. So HW, p-value for the H is 0.0001 and then p-value for the W is 0.0000, p-value for the HW is 0.0000. So all the p-value is less than 0.05 and also small. Then you look at the coefficient of determination. coefficient of determination for the simple linear, we take this value. And for multiple linear, we look at the adjusted R square. So which one is the highest coefficient of determination? So the highest is HW. So the best model is here. Okay, so I repeat again. First, you choose your possible model. Okay, possible model here we have 7. So these are the 7 possible model. Okay, next, look at the p-value. C is discard because of p-value here is greater than 0.05. So because of the p-value greater than 0.05, any combination with C is not significant. That's why any combination with C is discard. Then you left with H, W and HW. Okay, when you look at the p-value, H, W and HW, all the p-value is small. Okay, then you look at the R square and adjusted R square. For the H, it is a simple linear regression. We look at the R square. Also for the W, it is a simple linear regression. Look at the R square. For the HW, it is multiple linear regression. We look at the adjusted R square. And then we compare with these 3 R square, which one is the highest? So the highest here is 0.87, which is the HW. So the best model, so the best model is here. This one. We talk about the model, we talk about the equation. Okay? So these are the solution just now. Okay, the best model is HW because smallest p-value and highest R square. Okay, so look at the exercise 5.6. You have about the cheese and then you have the equation. What is the response variable and what are the predictor variables? So what is your y and what is your x? Okay, do the regression analysis. Okay, summarize your result. Hence, determines the best regression equation. Okay, so what you need to do is first determine your x and then summarize your result and then you choose the best regression equation. Okay.